So this section now is on trigonometry and the use of trigonometry to resolve forces. That's the aim for this particular section. So as a reminder of some basic things to do with right-angled triangles, as has been pointed out, I need Pythagoras to do this. So I know that Pythagoras says a squared plus b squared equals c squared. Because I've used it a lot, I also know that to find one of the short sides, a, it doesn't matter which letter I use, is going to equal the square root of the long side's c squared minus the other side squared. So I know that formula and I can write it down, and you should do. Okay? This is a quick calculation. So all I've got to do is say, okay, that equals the square root of 12.5 squared minus 8.2 squared. Hit that in my calculator and I get the answer 9.43, which is an appropriate number of significant figures. And I haven't given you the units, so 3 significant figures is all you can say. So a quick calculation with a calculator, seconds work, which would be part of another larger problem possibly. Number 2, formula for the area of a triangle, half of the base times the height. Remember that because, of course, if you think about it, the triangle is half of a rectangle with lengths 12.6 and 8.4. So the area is half base times height. It doesn't matter which I call the base, 8.4 or 12.6. So it's a half times 12.6 times 8.4 will give me the area, which is 52.92. I haven't given you the unit. The significant figure's a bit over the top for that one, so what would be more appropriate, Daniel? 3 significant figures, yeah, because that one's only 2. So what is this to 3 significant figures? 0.9, yeah, 3 significant figures. And the last one takes us into today. I need to know the sine, cosine, tangent ratios. Well, it's one of them. What you have to remember is this is the angle I know, and so I'm interested in the one opposite. So the opposite is to do with sine, not cosine. The adjacent is to do with the cosine. This is the thing that's floating around inside my head. Sine is to do with the opposites, cosine is to do with the adjacent. Okay? So I've got that the sine of theta is opposite over hypotenuse. That's what that's telling me, this bit here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's the ratio. I've got to find the opposite, so I need to rearrange this formula for the opposite. That's h times sine theta, where h is the hypotenuse. So now just bang in the figures. X, which is what I'm after, equals 12.8 times the sine of 40 degrees. 8.23 to 3 significant figures. Anybody else? No, shouldn't do. Anybody else get a different answer? There's one thing that you may be doing wrong that could lead to a wrong answer on this. Anybody know what that is? What I tell you? The calculator can work in angles measured in degrees or radians. So if your calculator says a little r on the display, you're measuring in radians. So whenever you're working with angles, you need to check you've got the right measurement for angles, and we need to be working in degrees here. Later on we'll be working in radians, so you need to be switching from one to the other. So you just need to check your calculators in the correct mode. Okay? At the moment it should be in D for degrees, which it is, Daniel, is it? Yeah. So that I would just say is correct. Okay?